Greetings learners once again, and let's have a look at our practice problem number 4, which is question 4 from the 2021 November paper. We are still on arithmetic sequences. So we are given, consider the linear pattern. So if you remember, we did mention that whenever they say linear pattern, we are still talking about an arithmetic sequence. Let's have a look at the first question, 4.1. So 4.1 requires us to determine T51. And what you should see is that T51 is so far. What we first need to do is to actually determine the general term. Because after we find the general term Tn, we'll then be able to quickly substitute 51 into our equation and we'll be able to get what T51 is. So let's go ahead and do that. So we have a 5, a 7, and a 9. So what we need is for us to find the difference. So you'll see that we'll get a 2 and we'll get a 2. So two things which we need. Our A, which is always our first term, that is 5. And our D, which is the common difference, it is 2. And remember that our general term is always given by A plus n minus 1 multiplied by d. So we can go ahead and substitute. So our Tn will be, the value of A is 5, n minus 1 multiplied by A 2. So you will see that our Tn will be 5 plus, when we multiply the 2, we'll get 2n minus 2, which means our final answer for Tn, the general term, will just be 2n plus 3, because we'll have 5 minus 2. So we are now in a position to go ahead and find T51. Because all what we do is wherever we see n, we'll go and put 51, then plus 3. Then next, we just need to use our calculator and see what we do obtain. So if you do 2 times 51 plus 3, the answer you should get is 105. And this is the answer which they are expecting us to obtain for 4.1. So next, let's go for 4.2. So 4.2, they are saying they want the sum of the first 51 terms. So essentially, they want S51. So with S51, this is very easy. Look carefully. We already have T55. So T55, this here is the last term. And we already have T1, which is A, of which we found as 5, which is the first term. So it means the sum equation that I'm going to use is the one where our Sn will be n over 2 into A plus L. This is the sum equation that I'm going to use because I've already done the work above. So this means our S51 will have 51 divided by 2 into the first term we found is 5 plus the last term, it is 105. So if we go and punch this in our calculator, the answer we will get is, we get 2,805 as our sum, okay? And that is the answer which we expected to find for 4.2. So you could alternatively go the long way. But this, remember, is another way of calculating the sum. So next, let's have a look at 4.3. So 4.3, you should be able to see that there we are dealing with some sigma notation because of that sign that looks like a kind of an E. So the question requires us to write down an expansion of that, but very importantly, we need to show only the first 3 terms and the last term of the expression, of the expansion. So what I'm going to do first is to quickly write down what we have already. So we have the sigma sign, and we're starting from n is 1 up until 5,000. And our formula is 2n plus 3. So remember, if we want the first term, we must substitute n is 1, and then the second term n is 2, and the third term n is 3. So the first term is going to be 2 times 1. But what I'm going to do is maybe let me go to the next page, and then we quickly figure this out. So remember, we need T1, T2, and T3, and this here is our Tn. So your Tn is just that. So I'm going to use the Tn to determine what is T1. So T1 should be 2 into 1 plus 3, which will give us a 5. Then I'll go to T2, which will be 2 into 2 plus 3, which will give us a 7. And then I'm going to go to T3, which is 2 into 3 plus 3, which if you look carefully, you will see that we should get 9. And then remember, this n here tells us where we should stop. So the last term is at n is 5,000. So what does this mean? It means I need to go and find T 5,000, because we are required to show the first 3 terms and the last term of the expansion. So T 5,000, that will just be 2 into 5,000, then plus 3. We all know that 2 times 5,000, that will be 10,000. So we'll just have 10,000 and 3. So now if we want to express this as a series, we'll find it as follows. So remember, whenever they speak about a series, that should be a sum. So let's go ahead and put up the original sigma notation here, and then just express it, and express the expansion with the first 3 terms and the last term. So the first term is a 5. So we'll have a 5 plus 7, which is the second term, plus 9, which is the third term, plus many other terms afterwards, plus the last term, which is 10,000. I'll make some space. The last term is going to be 10,003. So that is what they were expecting us to do. Now it's just an expansion with the first 3 terms and the last term of this series. I hope this does make sense and you understand 4.3. With this said, now let's go and have a look at 4.4. So for 4.4, we are asked to calculate, we have that sigma notation and then plus another one, but the other one is a negative. So what we should note is the top part. So let's go ahead and deal with this. So if you observe carefully, but maybe before we go there, let me remind you of something which you are expected to know, which is that if we are dealing with a sigma notation, let's say we are starting from k is 1 up until n, and we have tk here, and then plus, we have another sigma notation. We're starting from k is 1, very importantly up until n, and let's say we have pk here. Because these values are the same, and these ones are also the same, I am allowed to do something like this. So I can have k equals 1, n, and then I just sum these. So it just becomes tk plus pk like this. Okay, that I'm allowed to do. So what we can do is to do this. We can see that the other one is 4,999, while the other one is 5,000. So in order for us to make them to match, we'll do one of two things. So let's write the first one. So if you look at this expression, what I need to try and do is to actually remove the term on the first sigma notation, the one that has 5,000, essentially the last term. So I'm going to add it on the side such that on the sigma notation, I only need to stop at 4,999 so that these are the same. What do I mean? Let's go to the next page and you'll see what I mean. So what I'm going to do is I'm going to say, remember the last term, that T5000, that is 10,003. So if I make this to be 10,003, it means now I only have up until 4,999 terms to sum. And this is from n is 1. And what we have here is 2n plus 3. But then it now matches with the other one. So which means I can say plus minus 2n minus 1. Okay, but maybe let me write that so that you can clearly see what happened. So if we go just below, what you will see is that these will combine into just one sigma notation. So we'll have 4,999, and this will be starting at 1, and we'll have 2n plus 3 minus 2n minus 1. And if you observe carefully, the answer will just have 10,003 plus our sigma notation. Let's pull it one down. And we'll have 4,999. And this is from n is 1. So if you observe carefully, this and this will cancel. And then we'll just be left with your 3 minus 1, which will give us 2. So now, if you think carefully of the answer, we are trying to sum 4,999 times. So the answer to this should be very simple. It will be 10,003. Then plus, we are summing 2 this number of times. So that is just the same as 2 times 4,999. And the answer will be 20,001. So that is what we find for that question. So what we have here is our final answer. So it is not a straightforward question because it required you to remember and to understand a lot of properties when it comes to sigma notation. But maybe as a thumbs up, what I can just make for you as a note, which is probably useful for you to remember, which is that if you are summing, let's say you have k is 1 and you have n and you have c, where c is a constant, and you are summing the constant n times, the answer will always be the same as c times whatever the n is. Okay, that is essentially what we did here. So what we did here is that our c was 2 and our n was that 4,999. So 4,999. So that is what we did. So please make a note of this and make sure that for future problems, you know it and you understand it. So this brings us to the end of this problem here, which is question 4 of the 2021 November exam.